Hello, everybody. Today we're going to talk about surface area. Okay, so the surface area is the sum of the areas of all the faces or surfaces that enclose the solid. So for prisms and pyramids, the faces include both the bases and the lateral faces. Okay, so what are those? Well, okay, so on a pyramid, basically you have a figure that has a polygon on the bottom with a bunch of triangles connecting up at the top at something called the vertex. And that's with a capital T and a capital V. Okay, now this base the base is the one, it's usually on the bottom, but not always. It's definitely, if there's a side that's not a triangle, that's the base. Okay, it can be a triangle though, in which case it's whichever one. If it's different than the other triangles, then that's the one that's the base. Or if they're all the same, then it's the one on the bottom. Okay, the triangles are called the lateral faces. All right, with a prism, that has two bases. They're parallel. Okay, and they're the only sides that don't have to be rectangles. Okay, actually, they're the sides that don't have to be parallelograms, but we're only probably going to talk about rectangles for the lateral faces. So remember, the lateral means sides. So this is a pentagonal prism because it's got a pentagon for the base. It's a pentagon, it's not a rectangle, therefore it's the base. These are identical, and the other faces are called lateral faces, and they're all rectangles. Okay. All right. In a pyramid, the base can be any shape, but the lateral faces are always triangles. In a prism, the bases can be any shape, but they must be congruent, and the lateral faces must either be rectangles or parallelograms. Okay. So, find the surface area of the rectangular box. Okay. So, the surface area means we're going to find all the faces and add them together, the areas of all the faces. So, here's the thing. The bottom of this thing is going to be 12 by 6 rectangle, so it's going to be 12 times 6. And the top is going to be identical, so there's going to be two of them. I'm going to multiply that by 2. Then we're going to add the right side, which is 6 by 7. So 6 times 7. But the left side is the same, so we're going to multiply that by 2. And then the front is going to be 12 by 7. And the back is going to be identical, so we're going to multiply that by 2. Okay, so that's all 6 faces. So this is going to be 72 times 2 is 144. 42 times 2 is going to be 84. 12 times 7 is 84 times 2 is 168. Okay, so let's go ahead and add these babies up here. So 144 plus 84 plus 168. It's 396. And that's going to be in square inches because it's an area question. Surface area is always measured in square units. And there we go. Okay, find the surface area of the pyramid. Okay. So this surface area is going to have the base, which is going to be a square at 6 by 6. And then we've got 4 triangles, and they're all identical. So we're going to do 4 times, triangle formula is half the base times the height. So the base is going to be 6, and this is called the slant height right here. That's the height of the triangle, so that's going to be 7. And now we just got to figure these out. So this is 36 plus 3 times 7 is 21 times 4 is 84. And so the surface area is going to be 120, and that's going to be square feet. Okay. All right, so then what do we got down here? We got a cylinder. Okay, a cylinder works just like a prism. It's not a prism, but it works just like one. Okay, so um, the surface area. All right, so here's the way you can do a cylinder. Is you can take a pair of scissors and you can cut the base and you can cut around the other base and then cut it up the side. You can lay this thing out flat and it becomes a rectangle with two circles. Okay, now the area of this circle is going to be pi radius squared, and the area of this is also going to be pi radius squared. Okay, now this right here is the height, and this is the base of the rectangle. That's equal to the circumference of the circle because it has to wrap right around here. That's going to be 2 pi r. So the area of this is going to be 2 pi r h. So then what we can get is we get a formula. It's 2 pi r squared plus 2 pi r h. And once you know, this is a formula I'd probably memorize that thing. Once you know it, it makes it super easy. Not a hard one to learn either. So this would be 2 pi. Now be careful because it gives you the diameter. We want the radius. So that's going to be 13 squared plus 2 pi times the radius is 13 again, and the height is 19. Okay, so let's get out our calculator. 13 squared is 169. Whoops, 169 times 2. So this part right here is 338 pi plus 2 times 13 times 19 is 494 pi. And then we add those together. So 494 plus 338 is 832 pi, which is approximately 2,612.48, and that's in square feet. It's a pretty big cylinder right there. Okay, not difficult stuff. Find all the areas of all the faces and add them together. Okay, now we got the cone. Now the surface area of the cone, I find the students have the hardest time with finding that. Okay, and I'm going to go ahead and give you a formula for that. The formula is going to be surface area is pi RL plus pi r squared. Okay, so pi r squared is the area of the bottom of this thing because that's a circle, and pi RL, this is the slant height right here. It's L, and of course the radius is just whatever the radius is here of the circle. Okay, so pi r squared plus pi Robert Lippy. So there you go. And then you just find the surface area. It's pretty easy. So pi times the radius, which is 3.5. Be careful of that again. Don't use 7. Times the slant height is 10. Plus pi times the radius, 3.5 squared. Okay. So 3.5 times 3.5, this is 12.25 pi here. Make sure you don't just multiply that by 2 as well, like a lot of people do. This is 35 pi. And so that's 47.25 pi. So we can go ahead and multiply that out. We get about 148.365 square centimeters. Okay. All right. This is a regular pyramid, which means all these triangles right here are identical, so you only need to find the area of one of them, really. It also tells me there's a regular hexagon on the bottom. All right, so if you remember a regular hexagon, we're going to make a formula right here. So if we do the base, the regular hexagon was 1/2 the apothem times the perimeter, plus, in this case, we have 6 triangles, so that's 6 times half the base times the height. So we've created a formula just for this figure right here. All right, so the apothem is given to us to be 8. And the perimeter, this is 9 times 6, that's going to be 54. Half of 6 is 3, times the base of the triangle, which is 9, times the height of the triangle, which is 14. Okay. And now it's just a calculator question. If you get to here, you win. So half of 8 is 4 times 54. This is 216 right here. 3 times 9 times 14, 378. And we just add those together. We get 594. And that's square centimeters. Okay. So, don't try to memorize formulas like this. Just create them as you go. You know the base was a regular polygon. There's my regular polygon formula. I already know that. Okay. I know that these faces are identical. There's 6 of them, so I'm going to multiply by 6 the area of a triangle, which is half the base times the height. There's my formula. Write the formula down because it tells you what numbers go where, okay, and what numbers you need, and boom, you're done. Okay, you get to this part, it's gravy to finish it up. Okay, find the surface area of the box with a cylinder removed from the middle. So this is like there was a box and somebody drilled a hole through it. Okay, so we're going to start out, we're going to find the surface area of the box. That's easy to do. Okay, so that's going to be, the bottom is going to be 25 by 15, and that's the same as the top, so it's 2 times 25 times 15, plus 2 times the left side is going to be 60 by 15. That's the same as the right, plus 2 times the front is going to be 25 by 60. Okay, there's the box. Now, when I drill a hole through it, I eliminate a circle in the front and a circle in the back. Those are gone. So I need to take this right here and I need to subtract 2 circles. So that's 2 times pi times the radius squared. Okay. But also when I drill this hole and I eliminate these circles, I open up the inside of this cylinder. Okay. So the cylinder looks like this. Okay. So the circles here is what we cut off of this thing. The height of the circle is this distance right here. So this is 15. The base of the circle is going to be the circumference of the circle. So it's going to be 2 pi times the radius, which is 5, which is going to be 10 pi. Okay, so we have to add that back. We need to add the inside of this. So that's going to be the base 10 pi times the height. Okay, so I have now created my formula. Uh-oh. That goes there. Okay, now I just got to figure out what all this is. Okay, so I get out my calculator and I'm going to start out, let's get a different color here. 25 times 15 times 2, 750, plus 60 times 15 times 2, It's 1,800. Plus 25 times 60 times 2. That's 3,000. Minus 2 pi times the radius. Now the radius was 5. Okay, so that's going to be 25 times 2 is going to be 50 pi, minus 50 pi. Plus 15 times 10 is 150 pi. All right, now let's consolidate all this. So this is going to be 4,800 plus 750. That's 5,550. If I combine these, that's going to be plus 100 pi. There's my exact answer. So if I get the approximate answer here, this would be 314 plus that would be 5,864 approximately. And that's going to be in square centimeters. Okay, so here's my exact answer. Okay, there's my approximate answer. All right, what fun that was, huh? All right, here's a little worksheet for you. Enjoy that, and I will talk with you guys later.